Hey, hi Modern, nice to see you again. Um, jam, surely, surely we will jam. Yeah, I love that song. Even I think more in the live version, just because the cheering of the fans is just giving it a little more touch to it. I think. Um, okay, so. I'm late again, this time because I needed to eat and started too late making food, and then was on eating and couldn't stop. You cooking now, can't chat much, but listening. Good luck with the food. Hope it will be tasty, and don't worry about that. Yeah, okay. I think I'll just start with C++ here and then do the tutorial. We'll do that, I think, only 2 hours today till 9. And then try to also do only 1 hour magic so that I can make some progress with the animations and maybe finish the character of Puppery that we're currently making. That should be possible in like 3 hours, I think. So yeah, we'll try to do that. Okay, but other than that, I think I'll just gonna start reading. Oh, and like, I'm not sure how that's called in English. My nose is a little closed currently because the like we have a new dog here and I have like allergy, and then some days ago the dog like pissed on the floor and the vacuum robot went through it, and then we turned off the vacuum robot to like after cleaning, so the before cleaning, so the electronics won't break, but then we forgot to put that back on, so for several days now the robot didn't clean, and so yeah, I can feel that in my nose. So I might be like talking a little different, um, or like needing to brush my nose more often. But yeah, I think it will be fine and just a little annoying. Okay, with that, let's start reading. So we were done with the modules last time. Wasn't the best chapter. Like, concepts really hyped me up for modules and like the way and detail they made that. And then the modules were just a little more information that I already had. But we'll see how it goes with the remaining chapters. Yeah, okay. Three-way comparison operator. Ordering before C++20. Compare the method of ordering before and after C++20. The three-way comparison operator, smaller than equal, bigger than, or greater than, is often called the spaceship operator. The spaceship operator determines for two values a and b. Whether a is smaller b, a is equal b, or a is bigger than b or greater than b. You can define the spaceship operator, or the compiler can auto-generate it for you. The appearance or to appreciate the advantages of the three-way comparison operator, let me start with the classical way of doing it. Ordering before C++20. I implemented a simple int wrapper, my int. Of course, I want to compare my int. Here is my solution using the function template is less than. Okay, let's see. Do they describe that again? Not that much detail, so let's look at this. We have the struct my int, it has value, constructor, and then the smaller than comparison. Then we have a template function, the is less than function. And then later I think we'll just, we just use that function. And then it states true for this, which makes sense. Honestly, my int is an unintuitive type. When you define one of the 6 ordering relations, you should define all of them. Intuitive types should at least be semi-regular. We had that before. That I think the only thing missing for regular was equal comparison, right? Let me click on this. Okay, according to him, a regular defines these functions: copy, construction, assignment, equality, destruction, total ordering. Okay, and so then I think semi-regular, semi-regular is equality comparable. So, they're talking about like everything except like the equality, right? So smaller than and all of that should be there so that the type is easily usable and you're not getting confused why you can like smaller than compare it, but not the other way around. Okay. Yeah, always needing to define all those operators, or at least most of them, and then some dependingly on the other operators, just annoying. So that's nice if then the spaceship operator will actually replace that entirely. But we'll see. Now I have to write a lot of boilerplate code. Here are the missing 5 operators. Yeah, okay. Now let's jump to C++20 and the 3-way comparison operator. Ordering since C++20. You can define the three-way comparison operator or request it from the compiler with equal default. In both cases, you automatically get all 6 comparison operators. That's really, really good. Let's run that code again, but skip it first. The user-defined line 7 and the compiler-generated line 15 3-way comparison operator works as expected. Okay, line 15 actually just stating the operator and then defaulting it. Oh, and then for the other, they just use the spatial operator from the underlying int type in their myInt struct. So that's also straightforward. Then they define the template function for the comparison. And then the output is... yeah, the output is exactly as expected. So that's nice. In this case, there are a few subtle differences between the user-defined and the compiler-generated 3-way comparison operator. The compiler deduced return type for myInt line 7. Okay, they autoed the return of the operator. Okay. The compiler reduced return type of myInt line 7 supports strong ordering, and the compiler deduced return type of mydouble supports partial ordering. Floating point numbers only support partial ordering because floating point values such as none cannot be ordered. For example, none equals none is false. Okay, interesting. I would have expected the return type of this spaceship operator to always be like something like -110 or something like that. So I would have expected that to either be a special type or always be an integer or unsigned integer or anything like that. but it seems that is not the case, but some special type maybe, because like they say that the deduce type supports strong ordering or partial, but maybe they go into detail on that later. This is again a part where I not fully like the way they do this, because I don't quite understand the detail they pointing out here. Like they saying something that is valuable, but they don't give enough background for me at least to fully understand what they are referring to or wanting to state here. Yeah, but we'll take that. Take it as it is. Okay. Next page. The compiler generated spaceship operator. Learn how a three-way comparison operator works. The compiler generated three-way comparison operator needs the header compare to implicitly const express and no except, and it performs a lexicographical comparison. You can even directly use the three-way comparison operator. The three, I don't quite get the sentence. Maybe I just misread. The compiler generated three-way comparison operator needs the header compare. Oh, okay. And then there's the next mind jump, and then that auto-generated spatial operator is const expression and is no except. Okay. Is lexicographical comparison. Okay. Now I get it. You can even directly use the three-way comparison operator. Okay. More code. Direct use of the three-way comparison operator. The following program directly uses the spaceship operator. Okay, so we include compare. We create normal integer and then we compare them and see the results. Okay, and then we just do like check what the return value is, if it's like bigger, smaller, 0. And then we do that for string, and we do that for vector of ints. And we get the correct result, it seems. Yeah, that makes sense. I'm not sure why they state that. Like, how else should you use this in the standard way than use the default? But okay. The program uses the spaceship operator for int line 11, for string line 18, for vector line 25. As already mentioned, these comparisons are shown in the output are const expressions. I think const expr is const expressions written out, but I'm not 100% sure. And could be done at compile time. Yeah, okay. And could be done at compile time. Okay. Comparison at compile time. The three-way comparison operator is implicitly const expression. Consequently, I can simplify the previous program and compare my double in the following program at compile time. Okay, they give no explanation in detail, so we will look at the code ourselves. I ask for the result of the comparison at compile time, line 20, and I get it. Okay. So we create a double struct, we put our double in there, then we have a default construction with explicit const expression, not a default construction. We have a constructor with explicit const expression, then the spaceship comparison default, and then when we compare that, we create our const expression doubles, of our special double type or double struct. And then we do the comparison and look at the result. Okay. I never, not yet, used const expression in that way that much, but I'll guess that should be intuitive in that as the const expression is used from the type till the point where the resolution is, like even the resolution of is less than is const expression, right? So that will then be evaluated at compile time, because the inputs of the double are also there and fixed at compile time and later. Okay, that's nice to know. I should definitely look into that too. That's actually a nice feature to use whenever needed. Where I did like sometimes use that just when I know that it can be put there, but not like actually for a purpose to improve things. So I definitely should look into that at some point too. Not sure. I think it's a 14 feature or 17. I'm not sure. But okay, let's continue. Lexicographical comparison. The compiler-generated three-way comparison operator performs a lexicographical comparison. Lexicographical comparison, in this case, means that all base classes are compared left to right and all non-static members of the class in their declaration order. Okay, yeah. That all base classes are compared left to right. I'm not sure why base classes should be compared left to right and not up to down or bottom up, but I expect them maybe to order from left to right too, but this is not 100% clear to me. Okay, a non-static member of the class in declaration order. Yeah, that makes sense. I have to qualify. For performance reasons, the compiler-generated equal and unequal operators behave differently in C++20. I will write about this exception at the end of this lesson. Okay. The post. Simplify your code with rocket science, C++20 spaceship operator. From Microsoft C++ team blog provides an impressive example of lexicographical comparison. For readability, I added a few comments. Okay, they explain the code, so we'll read that explanation first. I assume the most challenging aspect of the program is not the spaceship operator, but the initialization of bases via aggregate initialization, line 2226. Okay, so we have a base class, a base struct. Oh, let me turn the record and then I continue. Okay. Yeah, so we have a basics struct which has int-char float double, defines the default spaceship operator. Then we have struct arrays which has int-char float double arrays, also default constructed, and then we have. Oh, now I understand. Then we have basis instead of basics, and basis inherits from basics and arrays. And so here in the listing of what we inherit from, there it goes from left to right. So basics member variables or non-static variables will be evaluated first before arrays. Before the struct arrays. Okay. Yeah, makes sense now. Okay, and then in the main method, we create two bases instances, A and B. Okay, and those then are aggregate initialized. Aggregate initialization enables us to directly initialize the members of class type class struct union when the members are all public. In this case, you can use brace initialization. Aggregate initialization is discussed in more detail in this section, designated initializers in C++20. We had that as a teaser before, somewhere in the first chapter. That now you can like name the variables, where you then still need to keep the correct order. But it seems they go into that in detail later on again. Actually, that's directly after this chapter, which is nice. I think we'll be able to do the three-way comparison today, because it doesn't look like much. Just some exercises, and then also do the designated initialization today too, before we switch to magic. Okay, but yeah, so we define those two classes, or the instances of these classes. And they seem to me to be equal. Oh yeah, okay, I think they are equal. We can't run this code snippet, so we don't see if that actually be the case. But most likely they explain what's important here, hopefully. They don't. Okay, then we'll just believe that everything just works, right? Okay. Good. Let's read the additional info. Optimized equal and unequal operators. There's an optimization potential for a string-like or vector-like type. In this case, equal or unequal may be faster than the compiler-generated three-way comparison operator. The equal and unequal operator can stop if the two values compared have different length. Otherwise, if one value were to prefix of again. Otherwise, if one value were a prefix of the other, lexicographical comparison would compare all elements until the end of the shorter value. The standardization committee was aware of this performance issue and fixed it with paper P something. Consequently, the compiler-generated equal and unequal operators compare, in the case of a string-like or a vector-like type, first their length and then their content if necessary. Okay, so that's just an interesting optimization note that sometimes you might want to do that and then default construct such an operator. Okay. Yeah, let's continue. Rewriting expressions. Discover how the comparison expressions trigger a compiler to generate a spaceship expression. Okay. When the compiler sees something such as a smaller b, it rewrites it to a spaceship operator. How do you say that? As a spaceship b, maybe? I think that could be a short form. Let's review that. When the compiler sees something such as a smaller b, it rewrites it to a spaceship b is smaller 0, using the spaceship operator. Of course, the rule applies to all 6 comparison operators. A operator B becomes A spaceship operator B operator 0. It's even better. If there's no conversion of the type A to type B, the compiler generates the new expression a 0 operator and then B spaceship A. From A to B. Okay, so basically it tries both directions. For example, this means for the less than operator, if A is if A spaceship B is smaller, the 0 does not work. The compiler generates 0 smaller than B spaceship A. In essence, the compiler takes care of the symmetry of the comparison operator. Let's need a little detail. Here are a few examples of rewriting expressions. We again have an integer with a private int value this time. We create that as a const expression. We have the spaceship default operator. Then we create ints and we create myints, and then we compare the myints. We compare myint with an int and int with myint. And I guess in all cases, yeah, in all cases it just worked. Okay. I used the less than operator and the corresponding spaceship expression in line 20, 24, and 28. Yeah, we saw that. And then those were directly, not moved. Converted into the spaceship, and that's why that worked, because the spaceship was default defined. Line 29 is the most interesting one. It exemplifies how the comparison integer smaller myinteger triggers the generation of the spaceship expression. 0 is smaller than myinteger spaceship integer. Yeah, okay. Yeah, okay, we'll take that. Honestly, myint has an issue. Its constructor taking one argument should be declared explicit. Constructors taking one argument, such as myint int val, line 6, are conversion constructors. That means that an instance from myint can be generated from any integral or floating point value, because each integral or floating point value can implicitly be converted to an int. Okay. Let me... I have no like button or something to mute myself. So I'm just gonna switch to BRB whenever I need to clean my nose. Okay. Yeah, okay. We take that as it is. And then there should be now an exercise. Exercise extend myint class. Extend the myint class to make it instance comparable. Challenge. Instances of the myint class can be compared. Extend the class so that instances of myint can also be compared with the int values. Okay, we can show some hint here, it seems. Try to solve the question below. Feel free to view the solution in the next lesson after giving it a few shots. Good luck. Okay. Let's click on the class. So then most likely we can copy the class at least. Yeah, okay. So we now have the class, and then we should extend it so that instances of my int can also be compared. I'm not completely sure what they mean by that. I would like, I'm not sure if I can just add an non const expression constructor, and that then will work. We'll see. Because that doesn't feel like an extension to me, right? Shouldn't I have, okay. Okay, I think I can also click here instead of me going to BRB. Okay, if the LG will be too bad, then I'll just end early, I guess. But we'll see how that goes. Okay, so what I wanted to do here, I cannot do, which is kind of strange to me because like I thought that if they want us to extend it, then sure they don't want us to just remove the const expression. So oh, hi Beef. We're currently doing the three-way comparison, and I don't understand their challenge here. But we'll see. Else I just take the hint and see if I can solve that then. But yeah, so they basically have this class, which looked like this, and then the task is to compare, to make it possible so that we can compare instances where before it was written so that const expressions can be compared. And I'm not sure what they mean with extend, rather than just removing the const expression here. But yeah, I hope you're doing well and had like a great weekend. Oh nice, the spaceship operator, yeah. It's actually quite cool how many operators were just replaced with that then so easily. So my first idea was then just adding a constructor without the const expression, but that's not possible because of overloading. So I wonder if I can just do something like this. But I guess I'll take the hint. I've not used the const expression enough to be skilled enough so that I know how to like use both things in parallel with the same class. So we take value, value, and then let's see if that works. If not, then we'll just look at the hint. Inverted constructor, you probably meant my int const, my int expression. Reference, yeah, sure. Yeah, let me check that here, if that works, and then I'll turn the record while that's running. Okay, I'm back. Currently, the allergy is definitely getting quite annoying. Because like I don't want to clean my nose every every minute or so. So we'll see if I continue streaming or I stop quite early. Because I also don't want to like sniff into the mic all the time. That's surely annoying. So yeah, we'll see. I hope that now that the cleaning robot is working again, because I'll turn it on again, that it'll be better in like a few days again. Okay, what a crazy mistake did I make here that this will not work? Oh, I didn't define the input. Okay. So this is now compiling, which is good. And then can we also add more ints here without the const expression and compare them? That will be interesting. Okay, back from that. Let's call that 2013, 2019 maybe. And then we take those two and we do the same comparison they did here. Those comparisons are like from their example before, right? And then we just replace these numbers here. And see if that runs. And if not, then we'll look at the hint. Did I mistype things? Oh yeah, we don't have the non-const ins. We also need that. Non-const expression ins. Let's do that. And then I would also want to like actually do that for all comparisons, right? Can I like replace stuff in here? Okay, I can. That's nice. That's really nice. Let's replace this with what do I call that? 13. I don't want to replace all. Okay. Replace those. Nice. And then we replace the other one with 19. Okay. And then we still have, I think, the integers to replace, right? So the these integers, but case sensitive. Where is it? Oh, there it is. There it is. This integer case sensitive, and then we replace that with the 19 version for those four. Then we save this and we see if this runs. And then I'm eager to find out. Oh yeah, okay. So everything everything here worked except the last one. Did I miswrite something here? The question will be if I want to find out why this is not working, or if I rather read their solution first. So maybe a hint here that we know which one worked and which didn't. And then also let's get more space there and then run that again. Because I have no idea if we're even on track to do what they want us to do. Okay, so the thing that is not working is the last one with the 2. Oh, maybe because of that? I'm not sure if this is relevant. No, that's everywhere here, the extra space. And we're using the... Oh, yeah, okay. Maybe we should have done that too, and then this too. So now the integers actually do what they should and have the correct value. We still don't get this comparison to work. So that is 13 and that is 19. Oh, for sure, because I messed this up. The values here should be replaced. I removed that the wrong way when I did that a second ago manually, right? Didn't realize I did that wrong. So 14 here, 14 here, 11 there, 11 there, 19, 19, 13, 13. Okay, and when I did the replacements, I just put 13 replacement here and the 19 there. So now this should work. Okay, it does. Nice. So let's save this, run again, and then we look at their hint, and we find out if we even did the correct thing. Make the constructor int explicit to support the comparison of my int and int. My int needs an additional 3-way comparison operator for int. Okay, so whatever I did here is definitely not what they wanted. I wonder if without that would still compile. But I definitely don't know enough about... Okay, it would still compile. Then I have no idea what they want with this extension for instance comparison. Let's see at the solution. Extend the myInt class. Okay, so they have const expression explicit myInt creation, so there will be no other conversions here, I guess, in integer from float or anything. Then they have the auto comparison, the spaceship operator for default defined, and they have the spaceship operator for const expression. Okay. And that they define over the spaceship operator over the subtype. Then they again do the less than comparison and output the results. I wonder if I want to look into this in detail and understand everything here, or if I'm fine with not getting this because I'm missing on const expression details here. The thing that confuses me is that in their description, it seemed to me that, like, so that the instances of my int can also be compared with the int values. Maybe I totally misunderstood that. Because what they compare here now, like we did that before already. Like we also have the myInt integer comparison here, and then the int myInt. Oh, though we didn't like use the spaceship here directly, right? We did use the spaceship Yeah, I have no idea about this task. And I think it isn't, like, it's something I will look up if I need that and something is not working. So I guess I just take it as it is here and read the explanation, and then that's it. Because I'm not sure what didn't work before and is working now. Like, I can't spot that. Okay. I defined the three-way comparison operator line 8 and declared it const expression. The user-defined three-way comparison operator is not implicitly const expression. The user-defined one is line 8. Unlike the compiler-generated three-way comparison operator, the comparison of myInt and int is possible in each combination, line 30, 33, and 36. Okay. And I guess that wasn't the case before, but it looked to me as it would have been. But maybe that was only because of implicit conversions, and then stuff might not be as we wanted. Because like it works here too, though here for sure the implicit conversions will happen, and it's not actual direct comparison. But okay. So this then is directly comparing the integer to the internal integer without the conversion. And like maybe that's the only goal that was here and I just didn't get that. Did we look at the hint that is here? Yeah, we did. Okay. Yeah. Okay. Then I just didn't understand at all, which is fine. The comparison of myInt and int is possible in each combination. We had that. Honestly, the implementation of the various three-way comparison operators is very elegant. The compiler auto-generates the comparison for myInt, and the user defines the comparison with int explicitly. Additionally, thanks to reordering, you have to define only two operators to get 18 equals 3 times 6 combinations of comparison operators. The 3 stands for the combinations int operator myInt operator myInt, and myInt operator int, and the 6 for the 6 comparison operators. Yeah, and we can do that with only 2 operators, which is nice. I think I now get where they wanted to go with the exercise. I either lacked C++ understanding here or English language skills, because I was so focused on instances that I thought they might be talking about not doing compile time comparison, but like instance runtime comparison, which like in review now makes a little sense. Yeah. So okay, they wanted to explicitly compare myInt to int and have no conversion. Okay. Yeah. I'll get that. We have all of this information. Let's continue. Definitely be using spaceship operator though. It's super helpful. User-defined and auto-generated comparison operators. Visualize the interplay of user-defined and auto-generated operators with an example. Let's run the code already. When you can define one of these 6 comparison operators and also auto-generate all of them using the spaceship operator, there's one question. Which one has the higher priority? Okay, yeah, I get that, if you define everything. For example, the implementation myInt has a user-defined less than and equal to operator, and also the compiler-generated 6 comparison operators. Let's see what happens. The compiler oh yeah, the spaceship, right? Yeah, okay. Line 16, yeah. Okay. We've run that. We see the results, and the results are equal, smaller than. Wait, what here even outputs things? Oh yeah, okay. These output things. So the output would be nice if we know which line is what, right? Oh, I think I need to, yeah, std. And then just do 1. And then we also do the ending here. Oh, I can't duplicate, okay. And then we'll just do this. I think I don't even need to increase the numbers. We can just count that here. Okay, so for the first line, we get the equal comparison. For the second line, where we have unequal, we also get the equal comparison and not the spaceship. Then for the third line, the smaller than comparison, we get the overloaded smaller than, and then for everything else, it uses spaceship. So greater than, smaller, equal than, greater, equal than will all be the spaceship, which seems to be mean that whenever possible, it uses the most specific option here. Okay. And then the most interesting would be like line 32, because here possibly it could use a combination of equal and smaller than, but it doesn't. So to see the user-defined equal and smaller than operator in action, I write a corresponding message to standard out. Neither operator can be const expression because standard out is a runtime operation. In case the compiler, in this case, the compiler uses the user-defined equal lines 25, 26 and smaller operator line 27. Additionally, the compiler synthesizes the unequal operator, operator line 26, out of the equal operator. On the other hand, the compiler does not synthesize equal operator out of the unequal operator. Okay, equal not out of unequal. I guess that is not seen here, but they're just stating that as an additional information. But we could just try that, right? So we do unequal here and then unequal there. I'm not sure that I feel like the later we get in this tutorial, the quality just decreases a little. With like such notes not being clearly an additional info, but to me at least seem like they should be seeable from the code. Okay, so the interesting thing here is now that the equal comparison does actually not use the special unequal, which means that if we want to specialize equal and want that to be used in both cases, we always should do equal instead of unequal. Which is also interesting because I'm not sure why that would be the case, but maybe they explain that, maybe not. We'll see in a second. Let me turn the record. Okay, similarity to Python. In Python 3, the compiler generates unequal out of equal if necessary, but not the other way around. In Python 2, the so-called rich comparison, the user-defined 6 comparison operators, has higher priority than Python's 3-way comparison operator comp. I have to say Python 2 because the 3-way comparison operator comp was removed in Python 3. Okay. That's an interesting side note. Good that we got that one, I guess. Distilled information. Okay. So we're basically done. Oh no, we need to test ourselves. Most likely it will again be a 4-question super hard task, right? Okay, but first distilled information. By defaulting the operator spaceship, the compiler auto-generates the 6 comparison operators. The compiler-generated comparison operators apply lexicographical comparison. All base classes are compared left to right in like their instantiation in the class. Not instantiation, in their listing in the class, right? Okay, and then all non-static members of the class in their declaration order. When auto-generated comparison operators and user-defined comparison operators are both present, the user-defined comparison operators have a higher priority. The compiler rewrites expressions to take care of the symmetry of the comparison operator. For example, if a spaceship b smaller 0 does not work, the compiler generates 0 smaller and then b spaceship a. Okay. Let's see what the test holds for us. I'm guessing it's because there's many ways for things to not equal. The act of being unequal does not imply being equal. Yeah, okay. I see that. Like further than just the internal value is the same. Like there could be a lot more. Interesting. But I thought like for certain things to be true, like if you want that to be like fully orderable or something like that. Well, no, there's just defined, I think for the regular type, right, which they also had sometimes here, it's just equal comparison should be defined, right? And they just don't talk about unequal. So yeah, I get that. I'm not sure if I have that right, but it feels like there's something that doesn't work in reverse. Yeah. Yeah, that's true. Like maybe the unequal also is just an optimized comparison, right? So the optimized might actually stop as soon as the first thing is unequal or is equal or something like that. Like whatever you do there, you might be able to do some optimizations. That's maybe why it's also not true in both ways, where the early break criteria maybe is not applying the other way around. Yeah, I don't know. It feels like there's a reason to me too, but I can't like grab to it on what exactly it is. Oh, I just thought that we only get 3 questions this time, so it's getting even harder. Okay, let's see. Choose the possibly correct answer. By default, the operator spaceship, the compiler auto generates. By default, the operator spaceship, the compiler auto generates the comparison operators. Is that a sentence? Like by the default operator spaceship, like if there would be a for, like for the default operator spaceship, the compiler auto generates which is 6 comparison operators. But maybe by can also be used here, and I'm missing English language knowledge. Nice that I combined that. English language knowledge is just English. Okay, yeah, I think this is easy. 6 standard were generated. Not sure what the question was phrased like. All base classes are compared left to right. And then if does not work, it generates. Oh, okay. This is the first tough one. We need D, I think. So we swap B and A, and we swap the operator from being. Oh, wait. We take the same operator, but we swap B and A, right? I think that should be right, yeah. By defaulting, it reads okay to me. Okay, interesting. Then I'm just lacking intuition there. By defaulting, the operator... Oh, okay, by defaulting. I get it now. I think I just misread this word. Yeah, I just skipped the ing. I just read like from default or for default defaulting. Okay. Nice. Yeah. This had some cool information. I'd say it was a little better than the modules chapter, but still not on the concepts level. Okay, we'll do that chapter 2, I think, and then I'll see what my allergy says, and if I switch, stop, or do whatever. Okay, so aggregate initialization. Learn what an aggregate initialization is with an example. Currently, I just rethought about the equal comparison. Maybe I should just quickly check that, because it's like some interesting thing, right? Yeah, the ing is important there. Like by driving, you can go many places. Yeah. That makes like I get that, reading it like that, it makes totally sense. Yeah. Okay, let's see. C++ 20. Oh, 30. That's sometime in future. Why no equal compare from unequal. That looks good. Let's see if this gives better results. Why don't C++ compilers define equal and unequal operators? No, that's too general, right? I'm just gonna scan through this real quick and see if something catches my eye, and if not, we'll just continue. Doesn't look good to me, I think. Let's see, unequal here. Default three-way comparison. The equal comparison function is called whenever values are compared using equal and unequal. Overload resolution selects the overload. Okay. Default equal comparison. Do we have a default unequal comparison too? Let's see. Unequal. Not equal. Okay, so I guess there's no easy way to find this information. It's like easy in the sense of just some quick research here. At least like not in the time that I would be willing to spend on this right now. So I'll look at these real quick and then we continue, I think, without like reading out, right? So that's a little quicker. Okay, here's something. Similarly, the unequal operator can be defaulted. It is deleted if overload resolution over x equal y, considering also equal operator with reversed order of parameters fails. Or if the result xy does not have the type bool, the default unequal operator calls not x equal y or not y equal x as selected by overload resolution. Defaulting the relational operators, okay, that's something else. So maybe it's actually only the detail that the implementation of the default depends on the equal operator, and maybe that's it, because we don't have like two possible implementations of that. And like the compiler isn't determining if it should use this or define like what has been the equal operator in this one, right? Maybe it's actually just that just the way it defines, it uses the equal operator and that's why it works, and then the other way around, because of that it surely doesn't. I think that makes sense to me. Okay. Yeah, I think I will take that as the, like, at least one reason maybe why that is the case. Okay. Aggregate initialization. Learn what an aggregate initialization is with an example. Designated initialization is a special case of aggregate initialization. Writing about designated initialization, therefore, means writing about aggregate initialization. I think we had a short introduction on this in the beginning already, but we'll see how much more detail we get here. Or maybe it's just some exercises that I then for sure will misunderstand and will mess around for nothing for a while. Let me mute for a and not forget to unmute. That would be annoying. I think I only once messed up and gone like to, I think, this one, and then did not click back to actually show what I'm talking about. So hopefully it stays with that one mistake for a while. Okay, introduction. First, what is an aggregate? Aggregates are arrays and class types. A class type is a class, a struct, or a union. Okay. With C++20, the following conditions must hold for class types supporting aggregate initialization. No private or protected non-static data members. No user-declared or inherited constructors. No virtual, private, or protected base classes. No virtual members. Struct point to D, class point 3D, defining public int xy and the other xy that. Okay. Yeah, and then we can use the, I think, curly brackets is the word to initialize that. Nothing special here. Line 16 and 17 directly initialize the aggregates using curly braces, not brackets. Curly braces. The sequence of the initializers in the curly braces has to match the declaration order of the members. The lesson on three-way comparison operator contains a more sophisticated example of aggregate initialization. Yeah, we've seen that there, where they also nested the initialization with sub-curly braces. Based on aggregate initialization, in C++11 we got designated initializers in C++20. At the end of 2022, only the Microsoft compiler supports designated initialization completely. Whenever that now comes, I fear that their explanation will be quite sparse because they were just not far enough with C++20 for them to give a full depth detailed explanation, but we'll see. Named initialization of class members. Get the details of designated initialization in C++20. Designated initialization enables the direct initialization of members of a class type using their names. For a union, only one initializer can be provided. As for aggregate initialization, the sequence of initializers in the curly braces has to match the declaration order of the member. Yeah, we had that syntax before, and then we also wondered why, now that we name these things explicitly, why we can't switch them, because I think it was or is not possible to put y before x here. I think that just does not work. At least that's what they stated. Yeah, okay. So let's return that, but I think what is possible would be to leave one out, or is that also wrong? That runs for a while. I think this should be fine as far as I remember. Yeah, I remember that. Still seems silly. Oh yeah, to me too. Let me turn the record while this is executing forever. you would figure the whole point of naming them would mean it could be order independent. Yeah, I think so too. But I guess what it at least gives an advantage, and even though that's not much, it's at least something, is that if we like now advance our point 2D, and we then would like make point 3D out of that, and at this in this place put the Z position, then this is like safe, right? Because the Z will not become the Y, right? So like this is an example where it might not be the, like you wouldn't put it there in general, right? But that at least is an advantage, that if you run this now, this will still, the 2 will still be Y and never become Z, or it will become a compile time error if you like actually switch like the order and stuff like that. So that's definitely like helping in some cases and more direct. But yeah, I wish they would have advanced it a little more. Yeah, definitely more explicit. Yeah. Okay. Line 18 and 19 use designated initializers to initialize the aggregates. The initializers, such as .x or .y, are often called designators. I wonder if I should, 1 second. I just recall that I like did not like for the title, right? I put 3-way in there, but we're already done with 3-way. Maybe I just update that. Not sure if that would make any difference anyway. I guess modules would be a thing that might get more interest, but I'm not sure if this will make a difference. But let's do that anyway. Okay, so I'm also in general not sure about like the title and naming stuff and all of this, or like the going live notification and all those things. Like I guess I should care more about that, because that's a chance to get people like to watch, right? Or to when they're in some searching for a channel, to click on it if the title is fitting. But I just don't know what would be good or not, so yeah, don't know. Anyway, line 18 and 19 use designated initializers. We saw that already, yeah. To initialize the aggregates, the initializers such as .x, .y are often called designators. The members of the aggregate can already have a default value. This default value is used when the initializer is missing. This does not hold for a union. Designated initializers with default, run the example below. We have a 1 and a 2 for Z. Need point outputs just the point. Okay. As long as you got C++ in there somewhere, you'd probably be good. Oh yeah, I think so too. And then also C++ 20 might already be enough. Maybe the details also wouldn't matter, but it would be like better in a way of hyping up the C++ 20, right? How's that called? Like more clickbaity maybe, or something like that, rather than just stating that I'm doing it, but like, I don't know. Line 17 initializes all members, but line 21 does not provide a value for its members. Also, it is fine if you only initialize the members that don't have a default value, such as line 25 and 30. 17 everything, 21 nothing, 25 partial, 30 partial. Let's see, why does... Oh, okay, yeah, this also does not run because Z and Y is switched again, right? Not sure why they didn't explain anything with that, just put that error there, but okay. Yeah, okay, we'll see. Maybe they come to that, but I guess not. And then the defaults are 1 and 2. Okay, and 1 and 2 are always present when they are not overwritten, which is only the case in 3. Yeah, the rest does not define Z, or rather this one defines the same Z value. Okay, the expression at line 29. Oh, now here it comes. I should have read that one sentence, that not read below and up. Okay. The expression at line 29 would not compile because Z and Y are in the wrong order. Okay. Difference between C and C++. C designated initializers support use cases that are not supported in C++. C allows initializing the members of the aggregate out of order. Okay, interesting. Maybe we get our reasoning then down here. Initializing the members of a nested aggregate. Okay, that would also be nice to have. Mixing designated initializers and regular initializers, designated initializers of arrays. The proposal P something provides self-explanatory examples for the use cases. Okay, valid C, invalid C++. Okay. Those things look really nice. The rationale for this difference between C and C++ is also part of the proposal. In C++, members are destroyed in reverse construction order, and the elements of an initializer list are evaluated. 1 second. Allergy is so annoying. The initializers are destroyed in reverse order, and the elements of an initializer list are evaluated in lexical order. So field initializers must be specific in order. So basically the statement is that it will be created in this order, but I think it will only be destroyed as soon as we leave that block, right? So I don't fully understand this. Yet. Maybe the next sentence will help. Array designators conflict with lambda expression syntax. Okay, I'll take that. Nested designators are seldom used. Okay. The paper continues to argue that only out-of-order initialization of an aggregate is commonly used. Yeah, I can accept that. This would be the real nice thing to have. And then I guess what we would need to do if we would make out of order, then we like could not directly set these, right? So for out of order, most likely we would need to get a temporary object, because I think maybe then this is created, set, deleted, created set deleted. And so that's then just conflicting with easy setting and would need special code to hold all variables, then match them, then set them. Yeah, sounds like pre-existing C++ stuff forced them to limit the scope of the designated initializers. Yeah, sounds the same to me. Okay. Distilled information. Designated initialization is a special case of aggregate initialization and enables it to initialize the class members using their name. The initialization order must match the declaration order. Okay. Exercise. Detect narrowing conversion. Detect a narrowing conversion with designated initializers. Designated initializers detect narrowing conversions. Narrowing conversion results in the loss of precision. Challenge. Extend the following program so that narrowing conversion takes place. Which error message do you get? Try to solve the question below. Feel free to view the solution in the next lesson after a few shots. I hope you will able to change the challenge. Let's see. Like, I understand the word narrowing and the word conversion. Like, in their own. I've read the following warning: narrowing conversion of buff size from int to unsigned inside. The compiler cannot determine how large something is. Like, it's reducing the thing, right? So narrowing conversion would then be from 0.3D to 0.2D. And then they want us to make that happen here, I guess. So that it takes place. Which error message would you get? So then I would expect that I should do something like this, maybe. And then I'm not sure how I should use that one here then. Like, I would expect to do something like this for the narrowing conversion, but that would no longer have to do anything with the aggregation, right? I'm not sure if I can do something like this maybe, or the dots on the other side. I think there's some way to put that, right? No parameter packs. Maybe I'm completely confusing this with another language, but I thought something like this maybe. Like going from double to float or long to int or float to an int, I think. Yeah, like I guess whenever we reduce the... Oh, okay. So they don't want us to be reducing or narrowing from 0.3 to 3D to 2D, but from int to something more specific. Okay. Yeah, but then like, can we just put that behind everything? Maybe that's what they want. Okay, now we get narrowing conversion. Float to int. I wonder though what their point with this should be, because like maybe it's just that now we only would get the information for y, which would be nice, and maybe before of this, without, we wouldn't get that detail. From to float to int. Well, it doesn't tell us that it's the y here. And then if we now maybe do this, does that now give a different error? Because there still would be the narrowing conversion. Yeah, it does. I wonder what their point with this is. Yeah, this works. And then in the case I change that narrowing type, I would get an error. But that also is true in both cases, without or with the initialization, designated initializer, right? And it doesn't even state that y is the problematic parameter. So I guess we'll see in the resolution or the solution why they wanted to point this out. Because I get now what they want from me, I think, but I don't get why. Okay. Try to solve the question below. Feel free to view the solution in the next lesson after giving a few shots. Okay, write your code below. Wait, what? What? So they it seems they didn't want me to adjust this, but rewrite it, okay? We just did that here, so let's see the solution. Okay. Yeah, so they also put that here. We got that in the help of your hint beef. Okay. They also added default values here for y and z. Okay. And then line 18, line 19, produce compile time errors because the initialization y 2.5, z 3.5f would cause narrowing conversion to int. Interestingly, designated initializers in C behave differently from designated initializers in C++. Okay, so they just let us do that for no purpose, right? That narrowing down is true whether we use designated initializers or not. I don't get that. Oh, hey, continue. Nice to see you. Hope you're doing great. Yeah, I feel like this exercise is just there so that this chapter has something in it. Not sure. Yeah, kind of weird just to point out C might not do that. Yeah. Though like C might do that too, right? Because like maybe it doesn't, but like that shouldn't be the point here, because it has nothing to do with like switched parameters or anything other they stated before. Because I think here yeah, they have not talked about the conversion in this part, right? So that's just strange to me. But yeah, I guess I'll just take that. Okay, just a weird exercise and solution, at least from my perspective on this one. But it's good to know that we get this narrowing conversion info. Okay, yeah. Let me turn the record and then We do the oh my god. Now the test is reduced to only 2 questions, where the last one was only 3. It's getting better and better with this tutorial. Yeah, but let me switch the record. Turn it rather. What we looking at today? We did the 3-way comparison, which also is called spaceship operator. And the interesting part is that all takeaway they actually gave us here is that if you use that one, where is it? Here, I think. No. Here. If you use that and you default define it, it will just replace all of the 6 comparison operators you normally would need, which is like really nice, and that's cool to have. And then that if you then specify special or like your own, for example, equal comparison, then that will be used rather than this general function. So that's all this chapter actually contained. And then we just had the designated initialization, where you can now with C++20 name the variables that should be initialized when you use the aggregate initialization. And then that's cool, because if you now would like remove something here or add another variable here, then you would get a compile time error, or it would be default initialized, but the y would always be y, right? So that's nice too, but it would be nicer if you could have any order here, and that is not possible for some reason, so you couldn't do z and y. And basically that's it. Like, that's the rundown of all that we had learned from all these things here. Pretty good to have. Oh yeah, definitely. Those are nice features. Definitely nice improvements. I'm only critiquing the way they were presented to us a little. But maybe I'm too spoiled from the concept chapter, which I loved. Like, that was super good. Okay. Question 1 of this super hard test. In aggregate initialization, the initialization order must match the declaration order. Yes. In C++, members are destroyed in the reverse order they were constructed. Okay. Hope you did well on the quiz. Yeah, we did. Do we want to, like, I don't have channel points, but if I would have, like, be at a point where I can have channel points, I would now do a bet on if the test for the next chapter would contain only 1 question. But I can't. Okay, it's still not that late, so I guess we'll also do this part, I think. It also seems quite short. And then template improvements is also short. Yeah, but I think we do that then next time. The allergy is definitely also hindering my thinking, not just annoying. Okay. New keyword: const eval and const init. And it seems we first do const eval. Okay. Understanding the use of const eval keyword in C++20. This kind of would hint me to some diamond-shaped resolution, but we'll see. Wouldn't fit for the naming for me. With C++20, we get two new keywords, const eval and const init. Keyword const eval produces a function that is executed at compile time. Okay. And const init guarantees that a variable is initialized at compile time. Now you may have the impression that both specifiers are quite similar to const expression. To make it short, you are right. Before I compare the keywords eval, init, expression, and good old const, I have to introduce the new specifiers eval and init. I think we had that in the first introduction here too, but they didn't go into any detail with this, so this should be all new. And quite interesting, because the way they did that before with things, they also explained the current state always, right? So that would be nice, that I also then like get another quick rundown of const expression here maybe too, in depth, but we'll see. Introduction. The const eval creates a so-called immediate function. Each invocation of an immediate function creates a compile time constant. To say it more directly, a const eval immediate function is executed at compile time. Const eval cannot be applied to destructors or functions that allocate or deallocate. Okay. You can only use at most one of const eval, const expression, const initialization as specified in a declaration. An immediate function is implicitly inline and has to fulfill the requirements for a const expression. Okay, so it's basically inline const expression. Explanation. The requirements of a const expression function in C++ and therefore a const eval function are: a const eval const expression can have conditional jump instructions or loop instructions, have more than one instruction, invoke const expression functions. A const eval function can only invoke a const expression function, but not the other way around. I wonder if a const eval function can also invoke const eval function, but I guess that should be the case. Use fundamental data types as variables that have to be initialized with a constant expression. Const eval function cannot have static or thread local data. Yeah, that makes sense. We have a try block, have a try block or go to instruction, invoke or use non-const eval functions or non-const expression data. To make it short, all dependencies of const eval function must be resolved at compile time. The following program applies the const eval function square. So we have a square here, we do an int 5 and then we do square with it, and then we can't run that for a non-const int. And the error will be yeah, int b is not const. That's a nice error for that. Let's get that back, rerun, and read their description. I think I've read a bit about this. Const eval and const init are guaranteed at compile time, whereas const expression isn't guaranteed and might be executed at runtime. Waits to see if he's right. Okay, yeah, that might be interesting. Though from the quality decline we experienced, maybe we'll not get that nice detail here, but let's hope they come to that. The number 5. Oh yeah, the int 5. Yeah, okay. Is a const expression and can be used as an argument for the function square root line 8. The same holds for the variable a, line 10, and constant variables such as a is usable in the constant expression when it is initialized with a const expression. Yeah, constant here, and then that's possible there. The variable b, line 13, is not const expression. Consequently, the invocation square root b line 14 is not valid. Yeah, we've seen all of that. Okay. Const init keyword. Introduction. Const init can be applied to variables with static storage duration or thread storage duration. Okay. So that's kind of more. Global namespace, variables, static variables, or static class members have static storage duration. These objects are allowed when the program are allocated when the program starts and are deallocated when the program ends. Thread local variables have thread storage duration. Thread local data is created for each thread that uses the data. Thread local data exclusively belongs to the thread. They are created at its first usage, and its lifetime is bound to the lifetime of the thread it belongs to. Often thread local data is called thread local storage. Did I misread, or is that now allowed? Can be applied to variables with static storage or thread storage duration. Okay, that's a lot more. Just by that definition, like at least for the init, maybe your point does not apply, but rather it applies for the eval, but we'll see. Const init ensures for this kind of variable, static storage duration or thread storage duration, that they are initialized at compile time. Okay, so it is actually ensuring that, rather than where it normally would be initialized at runtime. Interesting. Initialize as compile time. Const init does not imply constness, the declaration of a variable or object as immutable. Interesting. REST1 and REST2 have static storage duration, whereas REST3 has thread storage duration. Const expression, const init, and then thread local, res3, and they all were done with a const eval function. Okay. And we get all the values. Interesting. Yeah, seems like it. Oh, yeah. Interesting though. Like, I wonder how that is then mapped and done. So basically, this is kind of a storage trait against a runtime creation optimization, maybe. So that this is useful when you have enough memory to just put that in at compile time. Rather, and like increase your application size by that, I think, because you evaluate all the results rather than calculating that later on and then have more expense on calculating but less storage. I'm not sure, but maybe they also get to the point where this will be useful. Interesting. Never played with threads before. You mean like with these const eval init stuff, or like in general? Like as soon as we definitely did a lot with threads, but then only like simple joining stuff and that in general. Oh, I see. Did you just not use concurrency, or did you use other like non-standard libraries for that? Function execution and variable initialization. Explore the difference between const expression, const evaluation, const init keywords. Now it is time to write about the difference between those four. First, I discuss function execution and then variable initialization. Function execution. The following program has 3 versions of a square function. It's even worse with the allergy that I'm like, it's my own fault, right? Because I did turn off the vacuum robot but didn't turn it back on. That's even more annoying about it. Just never used concurrency. I see. Most of my projects have been pretty small so far. I see. Yeah, I think also like as long as you don't need it, there's no point in like you wouldn't stumble upon that, right? Only if it has some problem that isn't solvable otherwise. So yeah. Are you allergic to dust? No, I'm allergic to dogs and cats. And we now have a dog here, like quite fairly new. And I feared a lot that it would be might be very bad, but it was totally fine till yesterday and today. And so I figured that maybe the robot is not running, which normally is like running every day. So yeah, I hope that it'll just work out now that it's clean again. Otherwise that would suck a lot. But yeah, we'll see. The dog's so cute though, so yeah. It should just work. Oh, and also like my mom has, I think 5 dogs currently. So, and that was the same like for, like it wasn't 5 always, but I think at least 3. So all my childhood, there were always the dogs, and I'm not sure if I maybe later only developed the allergy, but I remember that my nose was always running. I'm not sure if that's an English term for that, but in German that's like how you say that. And like looking back, I think being like more angry kid and something like that came to like also that, because I always was annoyed with that, and I always like you're just not so relaxed if there's always allergic stuff around you and you're always breathing into that, and then don't know that and cuddle the dogs way too much and stuff. Okay, first automod. Let me see how I allow your message, and then I'll turn the record and then we continue. Oh, interesting. I also get the reasoning why in German. So it's because of sexual words. I definitely want to allow. And now the term lick me is allowed. I thought I just have automod off completely, because I thought like there was some checkbox that I didn't do, but yeah, I'm not sure why it has done that. Let me turn the record and then I'll read your messages. Okay, actually, this is nice. Like, I hear my own voice, so I know that when I don't hear myself, I'm mute. So I now fear less that I will ever not unmute myself, because I then would hear that. Totally worth. I'm allergic to rabbits, and we used to have one which loved to lick me in the face whenever I slept. Well, I think it depends on the strength of the allergy and if you can recover from that, right? When I'm like too long at my mother's place, there's just no place to hide, right? From the like 5 dogs produce so much hair and allergic things. I'm not sure how that's called. So yeah, there's definitely, like, I try to do that as little as possible so that I can be cuddling them for as long as possible, rather than like getting in the door fully and putting myself into them, and then I'll have to leave the next day because it's just too bad. Yeah, this wasn't meant to be totally sexual, for sure. Okay, I missed one, right? Yeah. Good old school example for const eval would be like the old lookup tables they used to use for the trig functions like cos, sin, and tang. Instead of computing those lookup tables and the client computer every time at runtime, you could use const eval to make sure it's done at compile time. Yeah, I get that. I wonder though what the like in that case too, it's also the trade-off between computing power or like computing speed to space, right? And like most of the time we have more than enough space nowadays, so yeah, I think it might actually boil down just to that difference all the time. Okay, so for functions, we've run this and it compiles. As the name suggests, the ordinary function square root runtime line 3 runs at runtime. The const eval function square compile time runs at compile time. The const expression function square run or compile time can run at compile time or runtime. Consequently, asking for the result at compile time with square root square runtime line 16 is an error accordingly. Using a non-const expression as an argument for a using a non-const expression for an argument for square compile time is also an error. Okay, let's see that till here. So we have the normal one, then we have const eval, which would be only compile time, and then we have compile time or runtime. Then this is invalid because we can't put that in a const expression. Those are valid, which is fine. And then here we have the normal function where we can put an int in, okay? We can put that into 2 in the runtime or compile time, and I guess here then the compiler deduces that this now will be a runtime execution because that must be runtime, and then that's actually exactly what you said. With this one, if we put that in, we would force this to be a compile time run, and therefore this cannot be possible. We get an error, so we could know that we need to make that const expression. So that's actually a nice advancement for this one, or a nice addition. So then with this, we can actually force it and get ensure that the compiler will complain if we are not fully compile time running this. Okay. we were at 23. The difference between const expression function square root run or compile time and const eval function square compile time is that square root run or compile time must be executed at compile time when the const requires compile time evolution. I think this is wrong. Or strangely formulated. The difference between const expression and const eval is that for const expression, it must be executed at compile time when the context requires compile time evolution, but else it does not. Maybe that's what's missing here, so I fully get that one. Yeah, totally off a trade-off. But even back in the day, those trigonometric functions were so heavy to compute that a few hundred bytes of lookup table was totally worth it. Oh yeah, sure. Like as soon as your compilation will get very complex, and you can just put that, ease that with the compile time compilation, that's so much worth it, yeah. Okay. Let's see. Oh, we don't even have an exercise for this. It's only this initialization and then the test, which might be only one question. We'll see. Though I guess here's way more that could be asked. Compile time, runtime or compile time. Okay. This one. So we might be able to get into the Magic the Gathering part soon, but I'm not sure if I'll be able to continue like after that and then also do animation and stuff. But yeah, we'll see. We'll definitely finish this one here. Okay, so static assert, the const expression version. Comparison here is compile time. Okay, then this array new with const expression function, interesting, is also compile time. So the evaluation is compile time, but then this assignment isn't, right? Or the initialization, I would say, isn't. Then this is compile time, this makes sense. Then that is runtime, because it's runtime variables for both. I'm so annoyed right now. Yeah. The problem is also that the only thing helping is going to sleep or like showering. But like that wouldn't help for too long, so maybe I should just run the robot in a second too. But it's quite late already. Oh, we'll see. Anyway, Yeah, this is runtime or compile time, it seems. I'm not sure why this could be both. Because like maybe that's just an implementation detail of the compiler, but this could be run at compile time, so I would expect that then always be the case, but okay. Yeah. The lines 1 to 3 require compile time evaluation. Line 6 can only be evaluated at runtime because A is not a const expression. The critical line 8. Yeah. The function can be executed at compile time or runtime. Whether it is executed at compile time or runtime may depend on the compiler or on the optimization level. Okay. The observation does not hold for line 10. A const eval function is always executed at compile time. Okay. Variable initialization. The following program compares const expression, const init. Only const variable line 12 is initialized at runtime. The const expression, const init variables are initialized at compile time. Const init line 17 does not imply constness, as do const or const expression. Okay. Const expression or const declared variable can be created as a local but not as a const. Yeah, I guess we stop soon. The const expression or const declared variable can be created as a local but not a const init declared variable line 20. Okay, let's see this. Const expression. Okay, const init. Increment me. And then we cannot increment. We can increment this one. This gives an error. What is res? Okay. The res result here cannot be incremented because it is const. The const init value can be incremented because it is not const, which is strange that it contains const but is not const, but I guess it makes sense in the naming, right? And then the const expression value cannot be increased because it is const. Then we have const expression auto local const expression, which works, but we cannot create the local const init as a local data member. Okay, so it's actually just static or thread variables that can be used with the const init, I guess. Let's reread this so I get that fully correctly. Only the const variable is initialized at runtime. The const expression, const init variables are initialized at compile time. Yeah, that makes sense. Const init does not imply constness, which is strange, as const and const expression do. Const expression or const declared variable can be created as a local, but const init can not be declared a local variable. On my way to the airport, to your business trip. I hope you have a lot of fun there, and that it will be really nice and maybe more vacation-like than actually just business. And I'm happy to hear how that all like turns out and how you like it all. Than like rather at pubs or next Friday or something, right? Yeah, definitely have a good time. And don't work too much, right? Okay, yeah, we had that part, you know, I think. We understood all of that. I still want the use case for const init. Like, that's actually a thing that I'm still missing. When that will be... Oh, well, now I get it, maybe, because it now can be altered, right? So we can use const init. Like, we can do way more at compile time now than before, because we can use const init for that. And use that in cases where it wasn't possible before. BRB gonna do the dishes, so have fun. Well, maybe not fun, success maybe. I wish you a lot of success so that you'll be done quickly. Okay, so we'll do those two, definitely. And then we'll see what my nose and allergy says to continuing with magic. Yeah. Solving the static initialization order fiasco. Okay, so this seems like example and details now, which I love. Get introduced to the static initialization order fiasco and learn how to resolve it. According to the FAQ at ISOC++org, the static initialization order fiasco is a subtle way to crash your program. Okay. The FAQ continues. The static initialization order problem is a very subtle and commonly misunderstood aspect of C++. Before I continue, I want to make a short disclaimer. Dependencies on variables with static storage duration, short statics, in different translation units are in general a code smell and should be a reason for refactoring. Oh yeah, it is such an annoying thing. And it gets even worse if you do that with DLLs and stuff. And then like we had a case where we needed that and it just doesn't work out at all. It's just super painful. Also, this is the same translation unit explanation as always, I guess. Okay. Consequently, if you follow my advice to refactor, you can skip this section. Okay. Well, there's still the case where the refactor would be way too much effort, right? Because the static... For us, it's not like a static variable, but a static class that is like managing stuff. Not doing that with static is just way more of effort, which we like wouldn't want to afford completely changing everything. Like in that DLL case, right? In the general would be fine. Okay, let's continue. Static initialization order fiasco. Static variables in one translation unit are initialized according to their definition order. In contrast, the initialization of static variables between translation units has a severe issue. When one static variable, static A, is defined in one translation unit, and another static variable, static B, is defined in another translation unit, and static B needs static A to initialize itself, you end up with a static initialization order fiasco. The program is ill-formed because you have no guarantee which static variable is initialized first at dynamic runtime. Let me turn the record and then we continue. Okay. Now that I scrolled, I lost track where I was. Oh, I think here. Before I write about the solution, let me show you the static initialization order fiasco in action. A 50-50 chance to get it right. What is unique about the initialization of statics? The initialization order of static happens in two steps, static and dynamic. When a static variable cannot be const initialized during compile time, it is zero initialized. At runtime, the dynamic initialization happens for these statics that were zero initialized. Okay. See there's a 50-50 chance that static B is 0 or 25. Changing the link order of the object files also changes the value of B. Static B 0, 25. The 0, 25. Okay. Static A, static A, static B. I wonder where the second static B execution comes from. What? Why does that happen? Static B is only here, right? Static B is then here executed. And if they do source main and run that one, source main, let's just call this method. I have no idea what is happening here. They compile main and source. Well, I believe what they state. I just don't see how this is happening. Like how the output is happening. I guess I'll just take it as that. Because we get this output, that's clear. And I get that calling this will call that, right? But I'm not too much into G++, GCC, whatever, into this compiling to know what exactly this does, and therefore what files I need to look. Okay. I'll just take it as their statement. Line 3, the main CPP declares the static variable static A. The initialization of static B depends on the initialization of static A, but static B is 0 initialized at compile time and dynamically initialized at runtime. That are those two lines here. That's still, I still got that one. The issue is that there's no guarantee in which order static A and static B are initialized because static A and static B belong to different translation units. That's what a fiasco. Oh, now I get it. Here we define static A, then we use the extern keyword, so we only use static A here rather than creating static A here, and then that is right why that are different compilation units, and that is why we have the problem, right? And then this is actually just two executions where we in the one first compiled main O, then source O, and in the other first source O and then main O. So that is what's happening here. It looks, yeah, it looks like you got it. It looks like the when the main is the first object to be compiled, static A hasn't been initialized, static B just being 0, and when the second object first compiles, the other way around. Yeah, okay. Yeah, what I was missing here is reading these two lines, right? I didn't get the difference between those two. Okay. Yeah. And then also I was confused with the 50-50 chance, because I expected actually like a runtime 50-50, which like didn't make sense to me, and then I got even more confused. Okay, but we got this now. And I think dynamically initialized at runtime. I think we have this one. The issue is that there is no guarantee which order static A or static B are initialized because static A and static B belong to different translation units. What a fiasco. The result of the executable depends on the link order of the object files. What can we do when we don't have C++ at our disposal? I hope they in the end also resolve this and tell us how we do that in 20 with an example, because like I know now that we should use then the init version, but I don't know how exactly, and if that would change something with the extern keywords or anything like that. Lazy initialization of static with a local scope. Static variables with the local scope are created when they are used for the first time. For us, by the way, we don't have the problem here that they have, because we have like an common entry point, which is definitely the first always. And then that defines the static main class that we have there. Though also that's a class, right? And then it does not have a concrete value, or doesn't need to have a concrete value for our case. Static variables are local scope. Static variables with the local scope are created when they are used for the first time. Local scope essentially means that the static variable is surrounded in some way by curly braces. This lazy creation is a guarantee that C++ 98 provides. Okay, with C++ 11, static variables with the local scope are also inherited in a thread-safe way. The thread-safe Mayer's singleton is based on this additional guarantee. Yeah, we use that one too, I think. Do they have an example here? Yeah, this one. Static singleton instance, then you return the instance and then have like static singleton. We do the exact same thing. Okay. The lazy initialization can also be used to overcome the static initialization fiasco. So this time static auto static static A is in a variable rather than defined directly, and therefore it's here in a local scope. And then, oh, let's run already. And then we create the value here, and then also create assign it. And that way, I think it's guaranteed that A is always runtime, right? Or like that B is not evaluatable before. Let's this time read their explanation directly. The static A line 6 in source CPP is, in this case, a static in a local scope. Yeah. The line 3 in file main CPP declares the function static A, which is used to initialize in the following line static B. This here declares. Okay. Currently wondering because like static A isn't static itself, but this is, right? We would still need to somehow compile source into main. At least I would expect that. But maybe this automatically makes this a static, but I'm not sure. We'll see. Declares the function static A, which is used to initialize in the following line static B. If the local scope of static A guarantees that static A is created and initialized during runtime when it is used for the first time. Changing the link order can, in this case, not change the value of static B. Yeah, we see this here. Okay. Compile time initialization of a static. Let me apply const init to static A. The const init guarantees that static A is initialized during compile time. Extern const init int static A. And then static B from static A. And then here const init auto static A. So this also became const expression here, right? Yeah, where it wasn't that in the first case. So that even could become const eval, right? Okay. Line 3 in file main CPP declares the variable static A, which is initialized in line 5 in the CPP source CPP, in the file source CPP at compile time. By the way, using const expression line 3 in the main CPP instead of const init would not be valid because const expression requires the definition and not just the declaration. In CPP line 3. So this could not be const expression because the value would be missing. What would be the error message here? Const expression in line 3 instead of const init would not be valid because const expression requires the definition of the declaration. Didn't we So maybe this is not a compile time problem then? Okay. Maybe that is resolved and fine because this is const init, right? So maybe that won't work then. Maybe it's deferred at runtime. Well, it should still, though, then fail now in the sense that the values shouldn't be equal, right? At least if they wanted to make that point here. So, like, I get that if we do that... Oh, I didn't change it here. Let's change both of them. Because I guess if one of them is const init, right? If this is const init, then it is defined at compile time. And so then that maybe is enough. But no, it seems to make no difference at all. Nothing seems to make a difference. Let's see. Let's try this. Because I think now we are equal. Maybe it doesn't actually apply our changes, possibly. Let's see. We just copy paste that down here. Equal, okay. Also equal. Okay. This shouldn't be like that. Like, we have now equal execution for this one and the one below, right? We copied the code over. So maybe this isn't just freely executing, because here we get the difference. And like below with the same code, and the same execution calls, we don't get the difference. So maybe we'll just trust them in their word. Oh, now we get it. What? Okay. But this is equal. Yeah. And this is equal to. That is strange. Okay, we still get that. Let's reset this. Discard the changes. Let me turn the record. Run this again. Yeah, I just decided that I won't do magic after this, I think. Just continue here till we're done and then we'll stop. My bad for that. But it's just very annoying to breath my nose, clean my nose all the time. Okay, so I want to try this though. This now that we reset it should work, but it doesn't. So maybe it only works for some reason when we run something else and then run that again. Maybe it does not detect the change in the way this thing works. Okay, so let's see. Okay, works now. And then they said that if we here do const expression, save that, run this one, and then run the one below, it should no longer work. Okay, let's see. Okay. Nice. Oh, I wonder why we couldn't have that directly, but we get it. We got it. Okay. Let's read the explanation again. Const expression is not valid because it requires a definition and not just a declaration. Okay. We have it now with const expression, and that's not possible because this is only declaration. Okay. Nice to know. So that's actually a problem solved with this. Interesting. Okay. That took way too long. But like it wasn't our problem, right? How could we know that run doesn't actually rerun, but does some substeps? Okay. Distilled information, because we take the last test here. With C++20, we got two new keywords, eval and init. Const eval produces the function that is executed at compile time, and const init guarantees that the variable is initialized at compile time. In contrast to const expression in C++11, const eval guarantees that the function is executed at compile time, rather than only optionally be computed at compile time, or conditionally. There are subtle differences between const expression, and const init. In particular, const and const expression create const variables. Const expression and const init are executed at compile time. Okay. Okay, 4 questions. It might be harder this time. The const variable is initialized at runtime. I'm actually not sure about this one. I'd say yes. Did you submit your answer? Do you want to move to the next question without submitting? Oh, I clicked here, right, and not there. Okay. Is initialized at runtime. Identify true statements. The const expression variable is initialized at compile time. The oh, this is again just two questions combined into one, right? Those two or those two? Like, I decide between those two and between those two. Okay. Whatever. Const init is initialized at compile time. The const init variable can be declared as a local variable. No. Const eval function is always executed at compile time. Yes. Nice. What a hard task to accomplish. Okay. We continue here next time. And I think I'm not gonna do magic now or animation because it's just very annoying with the allergy. And I hope that that will be better over the next week, and then I can do a full length stream next Friday again. Really sorry for that. I think I could have prevented that by turning back on the vacuum cleaner. Anyway, yeah, that's it for today, I think. Thanks for everyone watching and like writing and being here, and I'll be back next Friday again at 6 p.m. my time. As always, the your time will be down below the stream or in like the schedule, and if you like to follow, that would be really nice. And yeah, other than that, thanks everyone, and we'll see us on Friday. Well, it's the end right now, right? So you didn't actually miss it. Now that for once I'm in a record, I'll let the song run out, so you're fully in the end. Oh, no problem. Like you were also at pubs, right? I totally get that. So yeah, don't worry at all. Also, like normally I would have been live way longer, right? So yeah, no worries. I hope so too. Thanks.